so now the workshop is AI web development by Vernay and, well, me. So I'll hand over the time
live
to
stream Fasil. You're the tech
Vernay
Fasil, but
and
I'm the
me.
live stream Fasil. So we got
Very
ratio.
good.
How to handle.
Oh wait, sorry.
Exactly.
Oh yeah,
We got
okay.
ratio.
So can I confirm everyone here is for AI web development? Yes, right? Okay, any of you is running a Chromebook and cannot use Google Colab? Some of you have a Chromebook, but your student account does not allow you to access Google Colab, and you cannot sign into a personal email account on a Chromebook that is issued by school. Everyone has this problem because we'll be using Google Colab within the workshop. So if you cannot access it, then you have to figure something out.
By the way.
So just for everyone here can access Google Colab, right? Okay, very nice. If you have any questions during the workshop, you can raise up your hands, and some of the tech facilitators over there will try and go and address your questions. Otherwise, in between we have some short breaks, especially when transition between a bit of the AI part and the web development part. Then we will answer some of the questions that we are unable to answer. Alright, so when you start off with the AI part. Just hold on, we just load the slide now. Live stream for sale.
Good question. How the fuck do I do that? I don't actually know. Not that cable. Yeah. Why is it plugged into this?
Because the slides aren't on that computer.
Yeah, okay, that's your screen now, right? That's yours. That's your issue. That's your skill issue. That's not mine.
Hi. Hide the screen. Oh. Yeah, I haven't opened up PowerPoint. Okay. Oh, PowerPoint.
Hey, wait, all these people are staying for. Do you tell the Zoom people?
Right.
About the workshop?
Yeah. Can you confirm that Zoom is
You able to see what?
whatever you can see. Okay. You can see Ashwin and yes, right there. Do you want to join? Yeah.
What's the thing?
Yes, because it doesn't have to. Right. Okay. So. I'm using that. Wait, do you want me to do it? Is it live on Zoom? Alright.
Where's Icting? Okay, you're a MacBook user. Tell me how to change me.
How to change what? Escape. Enable editor. For some reason the animations don't come up. You don't enable it. Very stupid.
You use a Mac, Ashwin?
Yeah, I don't.
Okay, so does anyone want to tell me how the camera works? That is not what I wanted to do. Can you hear me?
You want to access the camera? Should I start?
Can you actually hear me?
Yeah. Okay, so I guess we'll start. We're going to be. So we're going to start with AI with Webdev. So basically, we're teaching you how to integrate AI models into your web development applications.
which may be useful for you during the hackathon as well. So basically, this is the content outline. We'll be teaching you what AI is, a basic introduction to NNs and RNNs. We'll cover that as well. And we'll teach you how to code a bidirectional Lsdm, hence why we asked you to use Collab for this, like this workshop. And we'll also be teaching you web and how to test the API. So yeah. Yeah. So what are not AI? Well, this is pretty self-explanatory. AI on its own is like one of the most important fields in computing and research, and it's a system that projects intelligence. So it's used for many tasks. So usually it's used for regression tasks, classification tasks, or clustering. So regression would be like predicting a value. Classification is predicting a class. Clustering is segmenting data into specific components. And there's also reinforcement learning. So reinforcement learning is using previous actions to dictate what you're going to do ahead. So it's like it's the most complex form of AI at this point, and it's supposed to be like on par with what you would see in science fiction with robots as well. So there are many like subtasks in all of this. So there's two different components that we usually deal with for AI. That being computer vision and natural language processing. So computer vision is just images, and natural language processing is text. That would be the most important way. So actually something that's not known very well is that neural networks on their own have been there since like 1940s, 80-year-old technology. So, but the rampant growth in the field only started about in the 1990s and 2010s, 2000s, with the introduction of the convolutional neural network and the recurrent neural networks. So these are two different types of networks that build on the neural network system, which we'll be covering in a while. And different systems like the LeNet, the GoogleNet, the AlexNet, the Vdl Lsdms, they all use these systems of NNs to optimize tasks. So usually CNNs, as in convolutional neural networks, are used in computer vision tasks, and RNNs, recurrent neural networks, are used in either like time series data, or also in if you're being deliberately proactive, you can also use it in text. So there are other algorithms as well, but people don't really use them as much. So like support vector machines, random forest, gradient boosting, k-nearest neighbors, stuff like that. But we won't be covering this just because it's not easy to integrate it into a website. So yeah, now we'll cover how a neural network or an artificial neural network works. So basically, the artificial neural network works on this concept of the perceptron, which takes in inputs, and then based on weights, which are represented by the variable theta, it manually like multiplies each value with each weight. So like let's say you have the first parameter x, y, then you multiply that by theta 1. If you have x2, you multiply that by theta 2, and if you have x3, you multiply that by theta 3. And then it just sums them up. So the sigma would be the summation symbol. I'm sure many of you know this. Then after this, you run this thing called the activation function. The activation function allows you to approximate a value between like 0 and 1. So that's where you use something like called the sigmoid function. There's also other activation functions like the ReLU function, and there's another called GeLU. So we won't be covering like a lot about it, but basically these activation functions help you in in like approximating a value based on the original sums, which gives you an output. Yeah. So how does this is the one layer perceptron, right? But how do you use a multi-layer perceptron? A multi-layer perceptron works like that, but it's like multiple layers of these perceptrons and multiple perceptrons in each of these layers. So it would be like, let's say you have these inputs, 3 inputs, which are represented by these nodes, and these are numerical inputs, right? Then you run this neural network onto this, and then it creates like 4 different nodes. This would be your second layer, which is one of your hidden layers. And what you're going to do is each line represents a different weight. So each parameter is multiplied by that weight and then given to that other perceptron. So those inputs on the perceptron are the ones that really matter to this case, I guess. Then similarly, 5 layers, and you can go back to 2 layers. And this is the 2 layers which we count as the output. So let's say you have to represent like it's a binary classification task, and you are doing one-hot encoding, which is like you give it 0 if like it's like basically if you have a class for Parkinson's and not Parkinson's, then Parkinson's would have the variable 0 and not Parkinson's will have the variable 1 in each column. So that's like how it works, but actually it's not necessary. You can just use one node for those kind of tasks. So this gives you your output, and you can use some kind of like approximation to understand what the outputs actually are. So yeah. Based on this, we get to recurrent neural networks and Lsdms, which are basically the most basic tasks for NLP. So they haven't been used much in the past few years with the introduction of the transformer, but due to the fact that transformers take hours to train, we won't be using that in this workshop. So basically, recurrent neural networks work on this concept of how do we analyze time? How do we analyze time series data? If you have a ball that's moving like this, so let's say this was your original position of the ball, and then you're saying that it actually had a velocity and it moved up, and then it continued having a velocity, of course, and it moved up, but it had a smaller like y displacement, and you know that what the downward acceleration is. Then how do you know what the velocity vector of the ball at time t equals 1 is, right? So this is technically a physics question, but you can use neural networks to solve this, and it becomes very useful when you're dealing with text, because text is sequential data, which means that you're keeping word after word after word. Unlike images, which are it's like a basic object, you can't really run sequential data on an image. So yeah, that's why this exists. So yeah, so recurrent neural networks basically remember previous inputs. So if let's say you have a neural network, and it's like you're inputting one data frame, like one sequential part of the data. So basically it takes one sequential part of the data, it puts it in, then it pops it out. Then it takes the other one, and based on weights it's already learned from the previous inputs, it trains itself to get used to the new inputs as well, understand what the new inputs mean. So it's like, yes, it's like just able to sequentially figure out a response. So there are two different types of RNNs, usually gated recurrent units or long short-term memory. So we'll be using Lsdms just because Lsdms are much more easier to implement. And on the other hand, you also have two options, unidirectional and bidirectional. So unidirectional would be like you go one by one through the data. Bidirectional is you learn the data, like the inputs before and the inputs after, and from there you make a decision. So this is used, unidirectional is used a lot in GPT-2, because GPT-2 is text generation, and text generation is mainly you have an input and you continue on the input. So you have to sequentially build up data. But bidirectional would be useful for this, since our task is much more pertinent to that component, I guess. So yeah, this is how RNN works. Basically, you have an input sentence, and you use this thing called a tokenizer to get specific values for each of these inputs. Then you run something called an embedding to create an array of each input. So what the input is it's just like the input tokenizer just separates them into like a set of words. So let's say 2,000 words, 20,000 words, which is what we're going to be using in our code. Then it runs embedding. So for each word, which already has an embedded value, it creates some kind of matrix so that it can communicate. So it can like find links between each and every array. So yeah, so when you run the embedding, it basically works similar to that, and you're just going to create like an array. So I think this is a 64 component array, and then after this, you run the bidirectional Lsdm, right? The bidirectional Lsdm takes each input one by one. So it takes the first array, runs through it, takes the second array, runs through it, and so on and so forth, until it's able to produce like specific outputs for each and every single one of the outputs. Yeah, so basically. Then what you do is you can run another dense layer, which is another layer hidden, and you get the outputs. So for example, let's say you have to predict 4 classes. Then you can do one-hot encoding, which, as I mentioned before, is basically saying is it or is it not for each of the classes. So let's say I want to classify whether someone is what classification? I guess let's say you have a tweet, and you want to classify whether it's hate speech, it's bullying, it's completely okay, and it's friendly, I guess. So you basically, let's say I write a normal tweet, right, which is like completely okay, but it's not something that's very friendly because it's Twitter. So what you can do is you basically say it's 0010. So 0 being that, oh, not hate speech. 0 on the second one is like it's not what is it called cyberbullying. The third is 1 because we said that this is a normal sentence, and the fourth is 0 because as we know, it's not it's like just generic, right? It's not something that's very friendly. So yeah, now let's get into coding the Vdl Lsdm. So we'll be using TensorFlow for this, and basically what we're doing is we're analyzing this thing called the Myers-Briggs test indicator. I'm not sure if you guys have heard of it. You can also go to this site, I think it's 16personalities.com, which highlights everything about this type of test. So basically you use the personality test, and there are four categories. You are either introverted or extroverted, sensing or intuition, thinking or feeling, judging or perceiving. So like for example, if you're someone who is very into computer science, it's very likely that you're going to be INTP. But it's possible you're ENTP or anything else because everyone has like specific qualities. But if you consider like the most generic programmer, they usually are INTP. So what is our task? Usually the MBTI runs based on like a questionnaire, right? What we're going to use is we're going to use a paragraph, and we'll use that to predict the MBTI scores for each individual. So basically we'll have 2000 inputs, which is like the paragraph itself, and you have 4 outputs. So the first output is your probability of extroversion over introversion. Second output is sensing over intuition. Third output is feeling over thinking, and fourth is judging over perceiving. So yeah, I guess we can get to coding. Go to this site and run this. Just open the notebook up. You'll see notebook settings, and you can run it on a GPU first. Yeah. If you're not able to run it on a GPU, just let us know. We'll share the model with you later.
Right, so everyone has taken over the collab. You're going to collab, right? So if any of you have issues with collab, just raise your hand and the tech facilities will come and help you. So that will be sent, yeah. So go to the link. Hold on. Okay, so the link is here, nush.link/bbcsai. So go over to it. Once you go over to it, there should be this collab file. You shouldn't be able to edit it. So what you can do is go to File, and then you can do Save a copy in Drive, and then you save your Google Drive account, and from there you can edit on your own file. So what you need to do is you need to change it to use GPU so you can run faster. So you need to go to Edit, and then Notebook Settings, then Hardware Accelerator, change it to GPU. So it might be none, and you just make sure it's GPU, and click Save. So we'll give it around, say, 2-3 minutes, and then if you have any issues anytime, like I said, you can raise up your hand, we'll come around and help you. Also, don't worry, the code won't work unless you fill in some blanks. So yeah, we've like made it deliberately difficult for you guys to just run through this workshop and not get anything. Yes. So I think that process will just walk around now and take care of it. You can get it to collab. So the collab link for those who don't have it, there. And we'll send it out in Discord channel. Okay. Just spend like 3 minutes on it. 5 minutes on it. Yeah. Copying the link. I think go to I think there's an AI So the link has been sent out in the AI Web Dev channel. I think we'll go around and just make sure everybody's collab is working fine.
Also, let us know if you have any questions regarding the content we've just covered in the AI part of it, because I mean, it's quite a difficult thing to get around on its own.
Yep. We can take questions now if you guys want. If you guys have any questions you would like to ask.
Yeah.
Alright, so it seems that everyone has collab set up, so we'll be moving on to the code.
Okay, so this is what we call Google Collaboratory. It's like a software where you can run Python on this thing called a notebook. It's based on a software called Jupyter Notebook, which you can run locally on your computer. Okay, so basically, Collab allows you to run like Python files on this system, and it's one continuously running kernel. So what we're going to do is we're going to show you how to use Collab in this capacity. So basically, this is where we did the imports. So we're only using like 4 libraries for this program, and we're using random, pandas, sklearn, and TensorFlow. So as you can see, there's a blank there. Okay, does anyone want to guess what's in there? What's supposed to be in the blank? Otherwise, I can fill it out. Okay. So type in chain test split. So chain. More visible. If you guys need me to zoom in a bit more, just let me know. So yeah, what we did was we used this function called chain test split in sklearn. So chain test split allows you to segment your data into testing and training data. So the problem with our current CSV is that it's very much not in that category. So yeah, that's what we've done. And for this, the blank should be raw.githubusercontent.com. So yeah, these 2 blanks, just make sure you fill them up. Now, what you can do to run them is you can press this circle, like basically, and you let it run anyway. So because it's a notebook that's not technically made by Google, so it will ask if you should be running it or not. Yeah. Okay, so it's connecting, right? Now, if you press this, you can actually see this system. We're not using it, but we'll be using it later just to download the model. So familiarize yourself with this specific system, I guess. Yeah. So this is your setup and inputs, and now to load your data as we did with this, we just fix the blank and we can just hit enter. So don't remove this unless you want to see a few unfavorable words, the sentences. Yeah. So this is like a real world data set. So people are known to put in a lot of unusual sentences in here. So as you can see, the sentences don't make any sense at this point, right? That's because we've removed these things called stop words, which are words that don't have any meaning. They don't really contribute to the actual discussion in the model. So people really don't use it very much. So yeah, we're just going to be using the words without the stop words. And now for training, we need to prepare the variables and split them into the train, cross-validation, and testing data set. So as I mentioned before, we're going to be splitting it into like the testing, training, and like those two sets. But we also need to create a validation set. So the reason for this is that when we're running AI models, we need to train it, and then it runs this thing called epochs. So after each epoch, it runs the model against some validation data to let you know if it's overfitting or not. So overfitting is like a normal thing that happens in AI nowadays, which is like you train the model for so long that it just gets so used to training it that it starts fitting to the overtraining data itself. It doesn't even care about the validation data. So that's why with body stopping, we just try to avoid that here. So if you want to know what the blanks are here, it should be xval and y test here. And then this should be tf.keras.preprocessing.text.tokenizer. And then this is the tokenizer code itself. So we'll be using inbuilt functions in TensorFlow to do the tokenizing. So this should be text.toSequence. Sequences. So this is where you create your x and y variables. So your y variables in this case are the I stack e split, which is basically us using 0 or 1 to denote whether it's I or E and or S and so on and so on. And after this we do the train test split. So we're creating a test validation size, like a general validation and testing size of about 0.4, just 40%. And then your test size, your test itself, which is like 40% of the data, will be split again into 10% of the data, which is now the test, the actual test size, and then 30% of the data, which is your validation test size. So yeah, so if we run this, I think I already did. Yeah. So you do this, and then you get to the model. So your model itself is, it's where you actually have to care about all of these systems. So if you remember correctly over here, you mentioned that it's 2000 inputs. So this variable here would be 2000. Yeah, basically. So embedding itself is, as we mentioned before, you take a numerical input and you convert that into a sequence that can be trained on the Vdl Lsdm. And it's basically trying to find relations between specific words and what that means in the context of this problem. So yeah, you create this embedding, and after this what we've done is we've created a bidirectional Lsdm. So bidirectional and Lsdm, and in the Lsdm we've taken an input of 64. The reason for this is because, as we mentioned, we're creating an embedding size of 64, and so as it takes each input inwards, so each 64 array input goes into the Lsdm, and it comes out as 64 variables. So yeah. So let's say you have the dropout rate. Then dropout itself is a normal thing that we do in machine learning, which is to introduce noise to your data. So dropout is like basically it removes nodes. Like in the computation, it will just remove the entire point of the node, which is to ensure that your model is good in case one of the nodes malfunction. Like it works without those specific nodes. So then after that, you create a dense layer, and as we mentioned before, this will be 64. Since 64 outputs are going out from the Vdl Lsdm. And then you create a dense layer of 4. And since we're finding a value between 0 and 1, we use this function called the sigmoid function. So if you want to, visualize what the sigmoid function is, it's like, it's kind of like you go from 1 to 0, and it adds 1 to 0, like the y variable goes there, and at x equals 0, the value is 0.5. So it's like a weird exponential function which we use a lot in this and also in statistics as well. So yeah. Um, yeah. This should work. Then in your model compilation, what you have to specify is the loss that you're using. So there are multiple different types of losses that you can use in models like this. There's something called binary cross entropy. There's other losses which have different varying names like Jaccard score and all. And so that's why we're using binary cross entropy for this, just because it's the most basic one. So yeah, I'll put it in here. So yeah, that's how you install the binary cross entropy. Then we're also using this thing called the Adam optimizer, which is used to optimize your learning rate. So how much you should be going down the slope to identify the minimum point. And there's also the metrics like the accuracy and the area under the curve of the ROC curve, which I won't be covering because they're difficult to explain. Yeah. So then after you fill these in, you can run a model. Yeah. So that creates this model, and as you can see, the output shape is already specified. Yeah. So then you can train the model. So we're using this thing called early stopping monitor, which is early stopping on this system. And we're using basically early stopping on its own is used for basically this entire task. So yeah, hold on. Open Discord. So just one note, right? This training process itself will take a while. So for now, Seth will be covering the API, but to cover what the AI itself should be, we'll be fixing this code out. Yeah.
Okay, so we understand that some of you are still working on code. So when you send the computer code to Eating in the comment section, we give some time to work on it first before I move on to the API part of the workshop.
Okay, to fix this is called callbacks, by the way. And now you can leave it to train. So this training process itself should take about half an hour. It may complete faster just based on the early stopping monitor, but don't be too positive about that. So you can let it run, and set will cover the API now.
Alright, so has everybody managed to catch up with the API, not the API, the AI stuff? If everyone is fine, then I'll move on. Okay, so this part is quite important because basically any of your web apps that you need to interact with our API. So basically, it's basically quite important. If not, you won't be able to build any web apps off the API because you don't have any data. So first I'll start with explaining what Sqlite is and what databases are. So we're using Python for our backend, for our APIs, and we're using Flask for the server, and the database we're using is Sqlite. So what Sqlite is a relational database. So first we go on with what a database is. So normally what people do is some people store their data in Excel spreadsheets, which is bad for computers because Excel is not very well formatted or consistent enough in such a way that it's easy for a program to access it. So what relational database is, it allows you to link multiple tables that are separate from each other. And what you can think tables as is different sheets in Excel. So say for example, I have a table and I have something called ID, and then from ID say I have something called students or name. So let's call this the students table, right? So within this table, I'll have the ID and then the student's name. In this case, I'll put my name. And then this is considered one record. So the ID name, they're called fields. And then each of this, the 1 and 7 is a record. And then you can have more and more records like 2, and then you can have 8, and so on and so forth. And then you can have another table. Say for example, class. So then you have, say, student ID, and then you have class ID. And then you can have student ID 1 and say class ID 6. And then you have another table, class table, which is basically the class ID and then the name of the class. So what this does, the class table does, is it links the two different tables together. It links the student, me, to a class of ID 6. So then I'll basically have another table. So let's draw this line, and then we have, okay, let's call this class student to make it clearer. Then we have another one called classes. So then we have ID and then class. So basically then we have say class ID, so it will be 1, 2, 3, 4, 5, 6, and then say class 6, and then we'll call it, we basically have a class name. So you might ask, why do you want to separate out the data instead of putting it together? The reason for this is something called normalization, and it's quite a complicated theory. But to summarize it, we basically do this to prevent corruption to our database and making it easier to access different data. So you won't really be designing databases. You may need to create databases and create tables. But I don't think it's really important for you to understand how to do normalization. So I think at this level, it's fine that if you combine all data into one table. Okay, so now we'll be going on to how to use Sqlite, actual code with Python. So currently what I'm showing is the API that will be available to you guys later to develop your web app. So currently if you like to test out this API, it's not actually, the actual server is not ready yet. So this is currently hosted on my server and my computer. So later we'll distribute the URLs to individual teams inside your Discord channel. I think Yiping and some of the other facilitators will help out with that. But, okay, so, first off, like I mentioned, the API is coded in Python and we're using the Flask server. So, I'll just give you a rundown of the code now, actually in detail later. So first we're importing the basic libraries. So if you're using, I believe some of you are using Gitpod for the web development part of this. Can I confirm that everybody has Gitpod ready? Big things. They have Gitpod ready, right? Okay, give me a moment. Okay, give us a moment. We need to set up Gitpod. Okay, can I check who doesn't have a Gitpod account? Like, all of you here is, okay. So, okay, to create a Gitpod account, give me a moment. Okay, so continue to go and help you guys with creating a Gitpod account. And the other tech facility or net will go out and help anyone who doesn't have a Gitpod account as well. So, sorry, one moment. Okay, so assuming you have a Git pod, all you do is go to new workspace. Okay, so I presume that nobody here has any repositories. So, one sec. Sorry. You want to create a new project, sorry, not new workspace, new project. And then you can, assuming you're using a GitHub account, you can just create a Git pod app. Then you can link it to your, you can link the Git pod app to your personal account. One sec. It's not loading. Dictate. If anyone else is having any tech issues, please raise your hand and our tech assist will come to you. Thank you. Try and finish up and look through the notebook if you haven't run your code for the model. So for now, please go to the report and then you can create a new workspace. And then you can create a new repository in that workspace, and then after that, you open up a VS Code editor.
slight problem. OBS quit unexpectedly.
Okay. So I noticed how you might need to create a new repository. So you know what we'll do instead is I'll push my code to GitHub and you can say clone my repository and go from there. So the code we're pushing is not complete. We're not giving the full API yet. So the full API, like I said, will be running on our server and you can access it from there. So for now, basically this code just allows you to see how backend works, and then we'll, from there, if you want to implement your own API methods, you can. And also it gives you a better understanding of how our code works and how you can integrate it with JavaScript to build your web app. I think it's easier for us that you just clone, for you guys as well, if you just clone our repository rather than creating a new one from scratch. Okay, so this is what your depot should look like. So for those who are having issues, I think I'll become resolving it. But I think the majority don't seem to have issues. So we'll be moving on. So this is what your depot should look like. So this is a file explorer. And if you like to change it to dark theme, you can go to settings, which is here, color theme, and then you can change it to a dark theme if you like. Okay, but basically this is a file explorer. You can click on this one of code, and below is your terminal. So for now, I'll be moving back to my For now, I'll be moving back to my IDE so that because this my server is hosting the API from there. Okay, so assuming all of you is working off my repository, you should be able to see the same code as I. Otherwise, you can raise your hand, contact the sales will go and help you. Okay, so I'll just give a brief explanation of the code. So the first 4 lines. Basically standard code to import the various library you need. So Flask, Sqlite, and Waitress. So Flask is the server itself, and Waitress serve from Waitress is basically what I'm using to host or to essentially make my server public. You actually don't need Waitress itself. Flask has its own option to basically host the server itself, but I don't recommend it. What do you mean?
It's super small.
Oh, okay.
And I'm sorry. You okay? Wait.
Okay, is this better? Are you able to see now?
Can everyone see?
Yes? No? Okay, so this first 4 lines is to import the libraries that we need. So the first and fourth line, the fourth line is technically not needed, but Gsonify is just something that was used very often. So we just imported it separately. But basically, these main 3 lines are what's needed. So Flask is the Flask server. Sqlite 3, like I mentioned, is the database, and we need the library so we can import it. And Waitress is the additional library that I'm using to host the Flask server. And as I mentioned, it's not completely necessary, but I'm using it because it's better in terms of functionality and security. So app equals Flask or Flask. This line of code is basically default needed to get a Flask server. So I won't be going through like these basic code because I don't think that relevant as compared to the actual API. So I'll start with this first line, line 8. At app.route, and then within it you have a string which is slash. So whatever is inside this app.route within this bracket, the argument is in a way the URL or the API endpoint. So what this means is that whatever your server URL IP address is, this endpoint, which is basically nothing, will return whatever this function defined below does. So my test server, you can access it if you like. It's test2.private.ps. I just send the link to this one if you like to experiment now yourself. So this is basically where my data is hosted. So the slash means that it's the index for standard web pages, but in this case it's just nothing after the URL. And so what this code does is it opens up a file from readme.md and then it returns a file. So if I go to file explorer and open up readme.md, you can see that this is the content. So it says hello and this is the building blocks conference API. Then when you go to the API or the URL, it returns whatever's inside the MD file, markdown file. Okay, so this is really very basic and it's not very useful because you're not actually retrieving any data and it's just in a way fixed. So now we'll be going to something more advanced where it uses some database and I'll explain the Sqlite code along the way. So, like I mentioned, the first argument is always an API endpoint, /students. So if I go to /students, you will actually see that some data is returned. So it's quite small, I'll just zoom in. So it's actually a list, and within the list is actually a dictionary object. Python this would be a dictionary object. Then you can see it's all of them the same data, class ID, the name, as well as the student ID. So if I go into the code, it basically gets the data from the database. So this is Sqlite. So basically I define the database object, which is Sqlite tree.connect to the database. So this database is a string, and it's basically the people.db I have here. So you have to connect to the DB, and then you only then you will access whatever data or tables, in this case you have inside the database. Then you create a cursor object with db.cursor. And after that, with the cursor object, you can actually execute actual Sqlite statements. So in database, there's actually 4 main operations, CRUD. So this is actually the retrieval operation where I read data from the database. So we use the select keyword to get data from the database. And then the three arguments here, the 3 things I mentioned, student ID, name, class ID, is actually what is returned. So if I go back to what's returned, there's actually student ID, class ID, and name. It's not in the exact same order because there's actually some processing done. So instead, so for example, right? Say for example, if I modify this, okay, if I open up a new Python terminal and just to demonstrate the Sqlite for a moment. So I basically imported the Sqlite module. Okay, so first I'll connect to my database. So I'll define it as available equals to Sqlite. I'll just run my first right. So now it's db Sqlite tree.connect and then people.db. And after that, I'll create a cursor object. Okay, and from there I can execute Sqlite statements. So like I mentioned, one of the statements is the read operation. So I can do select, and then like I mentioned, sorry, yeah? Sorry, give me a moment. Net. Okay, I'll continue on first, and later I think the tag cursors will have that. So, with the select statement, whatever I put after the select statement is the data I want to retrieve from the table that I select. So, you can use asterisks, which will select all records within the database. Sorry, all fields for the records that you are selecting. So, for example, there's student ID, which I use here. So, let's just say I get name only. Select name, and then I do the table, which is, in this case, the table is called students. So, from students, students is the name of the table. And so students is the name of the table within the database, and name is the field within tables, the table students. Sorry. Okay, so I do the fetch one method to get the first record. And then you can see I get the name only on the first record. And then I can do name, comma, class ID, and I also get the class ID. So like I mentioned, you can actually do asterisks to get all of the fields. And within the students table, there's actually another field which is the photo of the student. So as you can see, this is actually the photo of the student, which is actually stored in bytes or binary data. So it goes up very long, but the first three data that's retrieved is the student ID, the name, as well as the class ID. So, like I said, you can also do fetch all, which will actually get all records for all, basically which is all of the students. But I won't select all of the field because, as you can see, there's quite a bit of data for the photo, and that will basically crash Python. So if I do select name from students and I fetch all, it will just return a list of all of the records, and each record is an individual tuple. Okay, so then, like I said, the form here is actually referring to the table. So in another method for the API, another endpoint, I actually do /teachers, and I'm selecting data from the teachers table instead. So what I did here is I separated out the different data into different tables. Because what I want to do is have all the data in the students table to be the same. Because in a teachers table, there isn't actually a class ID, because in most schools, a teacher doesn't just teach one class. However, for students, they are usually only in one form class. So it wouldn't make sense to have a class ID for the teachers table. And if I put teachers within the same table as students, they basically wouldn't have a class ID field. It would just be empty. And the issue with that is that means my database is not, basically the records within my database is not the same. And when I try to get, say for example, get the class ID when it's a teacher, it could result in some errors. So by separating it out, in a way I ensure that all the data within that table is the same, and it could reduce my chance of errors. So like I mentioned, whatever is after form is the table you retrieve data from. And in this case, I'm selecting the teacher ID and name from the teacher's table. Okay, so I go back to the students method, the students endpoint. So like I mentioned, this basically selects all of the student ID, name, and class name from students, and afterwards it fetches all of the data, and after that I do db.close. db.close is very important because if you don't close a database, you could potentially corrupt or lock your database and prevent you from using it. So always remember to close your database after you've done all operations you need to. So this is the function. So this function is only called whenever somebody uses the /students endpoint. And so basically, after this operation, this cursor.fetch, that's the last operation I'm performing on the database. So I choose to close it immediately afterwards. And then whenever you do connect, you basically start or open up the database again. So you can always just reopen and reclose the database as needed. And like I mentioned, you can actually try out, like basically access this data, this endpoint with the URL I sent in Discord. So the URL is over here, and you can just do /students at the end, or /teachers, and then you'll be able to see the various data that's returned by it. Okay, so after that, I just define a new variable, which is empty list for data2. And so what I do is that, because the data here is actually not formatted, like I said, the data returned is actually a list of tuples. Okay, and I want to return it as a dictionary, or more, which is very similar to a JSON object in JavaScript. The reason I'm doing this is so that when you develop your web app with JavaScript, it's easier for you to deal with a dictionary object as a JSON object in JavaScript, as JS loves JSON. So here I basically get all the data and make it a dictionary object, and add all of it to data2. And I do flash.make response and JSONify it, basically converting the data2, which is data2 is, after I do this actually, data2 is a list of dictionaries. So I can actually do print data and print data 2 to demonstrate. I made a mistake. Okay, so can somebody try the /students method right now? Then I should be able to see, when you try it out, it should print out data and data too. Okay, thank you. Okay, so, okay, so from here, it's basically the data. So as I mentioned, whenever you do whenever you do fetch all, it returns a list of tuples, and each tuple is an individual record. But like I said, I want it to be more like a JSON or a dictionary. So, like I said, after I get data, I basically individually iterate through the tuple and then convert it to a dictionary. And then, as you can see, I print out data 2, which is essentially a formatted data. It's actually a dictionary, which is, say for example, this is one record that has been converted to a dictionary. So it's a list of dictionaries starting from here. And after that, I make response, and then I put in the data 2 and 200. So what 200 actually is the HTTP response code. So 200 stands for OK. So you won't be able to see the response code from here. I mean, you can see it if you do open up the, you might be able to see it from here in the inspector. But instead what I'll do is I'll go to, I can't see my own cursor. Okay, what I'll do is instead I'll go to command prompt, PowerShell. If I invoke web request, it basically sends a GET request to my endpoint. So this basically sends a request. By default, it's GET if you don't specify it, and it sends it to this endpoint. As you can see, it gets the status code 200 OK. So if I actually change the status code to say something like 404, right, which is 404 not found, if I rerun the code, and I try running it again, as you can see, I get an error because it actually still sends out the data, but there's actually an error. And the error is that, I mean, even though data is returned, the error is because I returned 404, and what happens is that my terminal actually thinks that there's an error and this thing doesn't actually exist. So the obvious difference is because of the response code, it actually, in a way, it actually still works by tricks PowerShell into thinking that basically there's nothing there. So when you decide to do your make response, what you should do is obviously set the correct response code. You can check the correct response code from I think Wikipedia has some it's basically the list of response code, but most common is 200. And by default, in Flask, if you access endpoint that is not defined, say if I go to this and I do /hello, which I don't have an endpoint named hello, you automatically return a 404 not found error. So it's not very common that you need to manually define a route and a response with 404 not found error, because there's no point in defining an endpoint and then putting 404 when you can just not define it, because you're not supposed to return anything there. Does that make sense? Because 404 is something that shouldn't exist on your server. Okay. So you might notice that my methods, I put something methods equals to get. So in HTTP, there's various methods like get, post, and put. So get request is, in a way, when a client sends a get request, it's trying to retrieve data from the server. So what this does is it only allows get request. So if I try something like a post request instead, I'll actually get an error. So I can demonstrate this in PowerShell. Sorry, give me a moment. Hold on, we are experiencing some slight difficulty. Okay, so as you can see, when I try a method that is not allowed put, right? The put method is basically to send data to the server. So one case you use put method is, say you want your user to give you data. So one example of this is, say we actually have a library database. So say your web app interacts with the library database. Say you want to get somebody wants to borrow a book. So then you need to update which books has been borrowed. So what you do is send a put or post request stating that, and you pass in some fields. Say for example the book ID, and then you send, say, another data saying that, oh, the book is broke. Then you send a put request, and what this means is that the server will actually receive the data, and then you update the database internally with the code, and then from there, then basically you update the record and say you refresh your page, and you show the book is borrowed. So you can see here when I try to put, it says method not allowed. Okay, it actually returns a HTTP error, and there's error code for method not allowed. But say if I allow the put method in my code temporarily for demonstration purposes, if I do this, and I reload the code, if I send it, and now you can see after I allow put request within my code, it actually doesn't return the error anymore. So, but the reason you shouldn't allow put or allow methods that you shouldn't really expect, right? You shouldn't really expect is because there could be unexpected errors. Because when somebody does put, they could actually be sending data to your server, and if your code isn't built in a way that it can react properly when, say, unexpected happens, like when they pass in data in the headers, your server application could crash, or it might corrupt your database. So by doing this in a way, plus in a way basically filters out whatever shouldn't be happening. And say your method is only for sending of data and you have nothing to retrieve, by setting it to only put or post, it basically prevents you from having to return your own error code. And the proper error code would then be method not allowed, because you're supposed to be expecting data, but the user is trying to retrieve data. And so basically the rest of this is the same code, basically retrieval of data from the database, formatting the database into something like a dictionary, and then after that sending out, which is basically returning the data, and then it's being sent out. So for example, like slash classes, you can actually try all this out because the server is running. You can do slash classes, and then you can see, again, it's another list of dictionaries, and then you have so basically the first field is class ID, class name, form, teacher, and grade. So you can see when I actually format it, it's in the same order: class ID, class name, grade, and form, teacher, ID. Okay, so this will be the end of the Sqlite and Flask section. We'll go on to the AI section, and after if you have any questions, I can come over and help you. But just to end off, to basically host your server, you have this code at the end. What this means is that if anybody accesses your IP address or your host name, it basically just runs the app. So all you just need to do is just copy. All you need to do is just copy this code, the end part, as well as the this first few lines, and then you can start creating your own custom functions and endpoints. Alright, I'll hand over the time to Bernie now to go on to the AI part.
Okay, so yeah.
Wherever you kept the collab.
Oh god.
No, that's not it.
There you go. Ah, wait.
Okay, it's fine. It's fine. I have it loaded anyway, so no. Okay, so with this link, especially if your runtime has disconnected, just go here. So you'll find the template file that was originally with all the blanks filled out. This will be the file that we will trying to make it work. And this is the final model. So what you have to go and is go into models and download this file. So yeah, normally you just download this. in terminal AI,
Yeah.
You can download it on
I will put it up on the report as well.
actual download. Yeah, exactly.
Wow. Okay.
Now it's my heart.
Okay.
okay, sorry about that. Yeah, I should now show you how to create that API server if I can figure out how to use this. So, as we showed previously, you just download the model. If the model is still training and your runtime is not disconnected, just run the other cells and get to the last part, then you'll see the models folder in the file directory called collab, so that you can download from there. I think we should, yes, that would be a good way to access it. So yeah, what I'm going to do here is firstly, I will go here and I'll show you how to create a class, a mini class server kind of. So basically in the API.py, we'll create a root called MVP live. So yeah. So it's app.root. Okay, so basically you create this root, and after you create the root, you can create the associated function. And in MVPI itself, what you're going to do is you're going to run the TensorFlow classification. So firstly, to do that, of course, you have to import the specific dependencies. So that would be really just import TensorFlow Lsdm. Oh, sure. Okay, so yeah, I sent the link into the chat, right? So you can just access the model from there, download it locally, and then upload it onto your Gitboard dashboard thing. So since I said it and that's loaded, if you need any help with it, just ask any of the technicians. So
Use Flask. How do you upload onto this again? How do you upload files onto this again? Yeah. Onto Cloud9, yeah. Helping someone else out. Yeah, that's what I'm doing here. That is not there. There.
Yes, give me a moment. AWS and servers are mine.
Alright, what's supposed to be uploading the file onto this. Because that's the point of this. Right. Where's the model? On your local downloads. I did that because it would be easier
Alright. So, okay. So here I'm using AWS Cloud9. The reason I'm using Cloud9 is because it's actually running on my own server, so I can host the API for other people to access. Because in a way, you host it locally, basically your computer will be running 24/7, or in a way, you publicly host your computer for people to access. But by running it on my own server and running the editor on my own server, it basically allows me direct access to my server, and having it being a server, it performs server function, it allows everyone to access. So, okay, so for now, like I mentioned, you actually be able to access our own API, which will be available to all teams. And basically, you don't need to host your own API or host your own code, and then we'll be able to host it for you. You can access it. And after you say you have some updates to your code that maybe you will use for your web app, so you develop your own part of the server. What you can actually do is you can upload your code to GitHub. And you can send us a GitHub repository, or if you don't know how to use GitHub, you can just ping us and we'll find a way to help you. We can actually help you run your code locally on our server, so that you don't need to run code on your server and then have the weird on GitHub. Okay, so what Penny is doing is loading the.
Wow. Okay, I'll rename it.
I think it's okay. So if the thing is Python is and how if there's spaces in your name, it can mess up slightly. So I suggest you don't save. In programming and comp science, usually you replace a space with a hyphen or an underscore, or you can do carol case. So one sec.
Yeah, then just go it.
Okay, one moment. For now, like I say, if you have any questions regarding the data, you can ask us first.
Yeah,
Wait, your directory is different. No model config knowledge is disadvantage. You might want to resave it. No model config file is found. Resave it. I think your save format is wrong. Find a different resave. You can do this model of save one.
yeah, that's what I did here. So we just save it.
Just do model of save. Model of save. Don't do save it. Model of save.
We don't have the model locally anymore. What do we have?
Okay.
Yeah, this is the model. This is the model I downloaded.
Okay, anybody here has fully trained model and has not have a collect die? Anybody have a model? Okay. Hi, grab your laptop. Because collect. Okay, the issue is when collect is a free service unless you pay for collect premium. So what happens is that in order to save your Google resources, because it's actually running real GPUs, real core nodes and Google server, you actually time out after a while. So normally what you do is you actually run the thing locally on your machine with either your GPUs, you run it locally on CPU, which is slower. But because you guys are all running on laptops, so not everyone has like powerful GPUs, and you definitely kill your battery life, right? So that's why we're using Collab. And like I said, not every laptop has a GPU. So the issue with if you get it locally, there will be a lot of issues with. Some people use Chromebook, definitely won't be able to run it locally.
Timeout because I was checking the code.
That's good. Okay. So assuming your model didn't crash, or okay, so maybe if not didn't crash, if you did timeout. Assuming it did timeout, what you could do is you could retrain the model at home, or if you have a GPU that you could use, you could train it again. But say you don't want to train it, you you can actually use our, like I said, we actually have the model that we upload, and then we also have the API which actually does use our model. So training your own model is, in a way, it's not necessary for you to complete the entire web app blah, but it's just, it's good for you to learn to explain it because it allows you to understand. Oh yeah, it died. Okay, so everybody's model exactly died because it's collapsed. So like I said, what I recommend is if you have a
it's fine. Actually, you can just use this. I'm just gonna copy the code for you. Yeah, it's just connected. Open your plan notebook, right? And then go to the place where we define the model. So, and then just copy this piece of code, this model equals here under this, and then write model or load weights into this. Upload your MVPI, and you should be able to load the model. Now, I'll just cover this stuff as well. So, this should be round. Then this should be apply maps. Yeah, okay. So load your data again. Since the data itself doesn't take too long to load. Separate the variables, but it's just so that you get a testing set. Then go in here, go to weights, do this. This will just load. Yeah. Then after this loads, you should be able to see that it has a pretty bad performance, about 10%. But that's because it's 4 different tasks actually. It's like it's the introverted, extroverted task, the intuition, sensory task, the feeling or thinking task, and the perceiving and judging task. So yeah, then if you test against random will do slightly worse. In this case, it did much better than expected. But yeah, as you can see, the model still does better than randomized variables. Now, this would be mixed models. So this is not necessary, you don't run this because we already showed you how to load the model. So if you don't have the model yet, just use this and you'll see the models, exact same model in this model folder. So don't need to download that.
Okay, so just to wrap up, like I said, the accuracy is low because if you learn in math, probability is, so sum of probability of the various things is just multiples of each other. So the accuracy of it is like 50% of each, and then 50 times 50 times 50 times 50, because it's 4 different inferences, then that's why it's bad. So some methods to increase the accuracy will be to train for longer with a bigger data set, and also to improve on your pre-processing, because for stuff like NLP, natural language processing, there's a lot of pre-processing methods that you could use. For example, in this case we did tokenization. We did tokenization, right? Yeah, but we didn't do vectorization, which actually converts the words into vectors or numbers, essentially. So there's a lot of NLP pre-processing steps. There's different models, different type of AI structures and networks that you could use. So this is a very basic model. As you can see, it's only 5 layers.
Yeah, technically.
Yeah, only 5 layers, and considering that 2 of them are input and output, we only have three hidden layers. So it's not a very complex model. And definitely we did not train it for long enough or with a very big data set. So you can work on this in your own time to try and improve the accuracy. And I think it's definitely possible to get something above 50% accuracy overall, which is really good for something like this. Right? Alright, so I think this is the end of our workshop. So again, any questions you can definitely post it in, I believe you can post it in the channel. You can find any of the facilitators and then they come grab us and can help you guys with any of your code questions. Or if you want to have a demo of the server part, like the API, you can definitely do that. So I believe now it's break, right? MC. Okay, so now what we're doing is trying to get our API to actually use the model so that you can submit some text and get some sort of influence. Yeah? Okay. now we have a 15-minute break. We should have 15 minutes after this, but give us 2 minutes to get this working, and then to do something with you guys.
Okay, guys. So what I want to do, right, is I want to just do like a short boomerang for like the publicity purpose.
Check. Can you hear me? Okay, yeah. So just really quick, I'm going to probably do a boomerang. Okay. I'm going to do a boomerang. This will be posted in the BuildingBloCS Instagram. Go follow if you haven't, by the way. So I'll just be doing it really quick. Okay. Give me a moment. Okay, once y'all are done, let me know. Then can everyone move to the middle?
Yeah, you don't have to follow this for now because we spent quite a bit of time and it will take a bit more to actually debug it. So currently, just like go on with whatever the task is that you want.
Okay, so like I said, in order to do a hackathon. So in order to do a hackathon, like I said, it's not recommended to start coding immediately. So you start by prototyping. So the API part of the AI part of the API will release it later, but the normal text-based data like the library, the facilities, like tabling, and student data, the API that part section will be released by the end of today, by the end of our conference today, which is around 5 p.m. And like I said, each team will have their own, in a way, their own API, because you may want to modify your code like I mentioned, and then we'll actually post it for you. So we'll update you with your specific team endpoints as well as any requirements that you might need within your channels, the individual team channels. Alright, thank you.
Okay guys, just to quickly wrap up. If you all are done, please come to the middle for like a quick boomerang. Let's go.
This guy. But I'm laughing in the background. This is my very sensitive.
Come on guys, please. The faster we take this, the faster we can also release you for break. There's pizza outside.
Thanks for watching the video. To watch more, do click on the playlist linked in the description or check out our channel for more videos like these. And if you liked, do consider subscribing to our channel. It really means a lot to us. Thank you and have a pleasant day.